So, good morning, everyone. Today, we are going to represent our Satkam report. Here are other group members. So, first question: the company wants to do an analysis of an app. What it needs to improve is mind map, top 10 features you would want to add in the app for electric scooter, and explain which are the top 5 features which will be useful and why. So first one is real-time scooter location using GPS. User needs to know the location of the nearest scooter while riding. The track should be available to follow. Battery monitor and range estimation. This is crucial for trust. No one wants to start a ride to only find a scooter can't make it halfway. Smart lock or unlock via app. A better user experience is provided by smooth unlocking with no key and code typing each time. Charging station locator. Add for a battery powered gadget. You must allow end users to know the location of charging stations subheading. Add emergency SOS and location sharing. Safety should be never a secondary thought. Riders may face breakdowns, accidents, or even personal emergencies. Here is the flowchart that we made. Next question: list of the potential reasons for any two of the issues which the customers have complained about, and write the test scenarios you will use to test and ensure they have been fixed. So first of the potential reasons is suspension system limitations. The present suspension is certainly tuned for smooth city roads, but it fails absolutely to absorb shocks while dealing with rough terrains. Second one is tire and wheel design. The tires may be either too narrow or have poor tread pattern, which limits the grip and control or on uneven surfaces. Test scenarios. Scenario 1. Simulate different riding conditions like hills, stop and go traffic, full throttle at low battery levels to verify estimated range remains accurate. Scenario 2. Carry out comparative vibration analysis with accelerometers before and after suspension improvements concerning rider comfort. Scenario 3. Test new firmware updates in the BMS for accuracy in predicting range and power delivery consistency. Scenario 4. Validate the warning notification system to ensure alerts and trigger appropriate thresholds.
So the question three is based on the list of top three features we have selected, do a relative priority exercise to mark them from P1 and P2, and then form 1 to 10 and explain what you have decided. The feature names are real-time scooter location GPS, second battery monitoring and range estimation, third emergency SOS and location sharing, fourth smart location and unlock by app, fifth charging station locator, seven vehicle fourth smart lock unlock via app, fifth charging station locator, sixth health vehicle health monitoring, seventh ride mode customization, eighth support customer support, ninth wallet and subscription plans, and 10th trip history and ride analysis. Why we gave this priority? We gave the highest priority to real-time location GPS because it is the most basic and important features. Because why would anybody open the app when no nearby scooter are available? Second, battery monitor and range estimation. The second based rides should know how far the scooter can go and the current charger. Nobody wants to be standard halfway. Third, emergency and location sharing comes next because safety is prime and can prevent mishaps. Smart unlock is ranked fourth because users prefer a smooth and keyless experience. It also adds security. Next, charging station locator ranks on fifth. So once the battery goes low, the user should find the charging station quickly. Next, the last point is the rest of the features like vehicle health, ride modes, and support are still good to have, but no, not as urgent. So we have put them in P2. Fourth, the question 4 tells us that the company is collecting the data in the cloud already, but they have performance issues to update. Collect the data and update the app. What can be the reason for that, and what would need to be improved for the integration from the vehicles to the cloud and to send the data post analysis to the app. The problems and improving data integration from the electric scooter to cloud. The reasons for performance issues are: first, network latency. Due to high latency network from low connectivity area, there can be problem in sending the scooter data. Data volume. Due to the large number of scooters, there will be a big amount of data generated which can cause volume issues. Third, data processing. As data is processed at cloud, inefficient algorithms can cause delay and slow in update the application. Fourth, cloud infrastructure limitation. The cloud infrastructure may not be optimized to handle peak load, causing problems and slow responses. Improvement of data integration. Data compressing. With use of better data compressing algorithm, we can reduce the data volume to be sent, thus increasing efficiency. Computing. By processing the data at source, we can reduce co-processing and volume, thus solving the bandwidth issues. Third, solution. By using scalable cloud network, we can solve the peak load issues, and over cloud can get big with data volume. Fourth, optimized network. Using cloud network and by using a content delivery network, we can send data to nearest cloud storage.
The company would like the app to have intelligence and provide recommendations to the driver. What kind of data should the app collect from the vehicle and what kind of recommendations can be done? Is it there possibility to use ML or AI for this analysis? And if so, what can be the use cases? Intelligent driver assistant app, data collection and recommendations, data collections from the vehicle data, speed, tire pressure, brake usage, route data, GPS, traffic conditions, weather conditions, driving data, acceleration, steering plot, use of turn signals, vehicle diagnostics, road plot, maintenance alerts, battery health. Types of recommendations: maintenance alerts, alert for upcoming maintenance and predictive system faults, also providing nearest service centers using locations. Safety alerts: the app can alert driver about the conditions and give feedback on his driving pattern and safety habits. Route optimization: the app can give updated routes using real-time traffic data and provide prediction about journey. Driving system improvements: the app can provide feedback to increase battery life and reduce scooter maintenance by giving suggestions. Use cases of machine learning and AI. Driving analysis: using ML model to provide personalized feedback for different users based on driving data. Real time traffic analysis: using AI and ML algorithm to predict and forecast future traffic and congestion to provide alternative routes. Predictive maintenance: using AI efficiently predict future failure system and fault, improving scooter drive time. Battery consumption: giving smart AI recommendation to improve battery performance and increase savings. Six, what can be the business and operational metrics and measurements the company can use for the new vision of the vehicle and goals they have for it? Business metrics can be around revenue, profits, etc., while operational metrics can be around quality, deliver time, etc. What all can be the metrics which companies measure their performance when manufacturing and selling electric vehicles? Business metrics: revenue growth. This is what the total revenue of the company is decided on. We manage the growth in percentage in comparison to previous EV model and its growth in terms of revenue. Return of investment, simple known as ROI. This makes sure to keep track record of performance vehicle in terms of its development and marketing. Customer acquisition cost, CAC. It is the ratio of total marketing sales to the new number of customers. This differentiate between the new and old customers. This, in short, keeps the track of all marketing, sales, and cost, salaries and benefits of the staff to the media spent, inventory turnover. This suggests how quickly the inventory is sold and replaced within every showroom, plant, or inventory storages. Market share: there must be different models existing in market, so we must know where a model stands in the market. This records the percentage of EV market captured by the new vehicle. Customer lifetime value. काय लावलंय? This is service based condition for customers. We must worth the customer value. This may customer lifetime value. This is service based condition for customers. We must worth the customer value. This may keep record of retention of अरे नाही रे. This may keep record of retention of gold customers for our acquiring service from our service stations. This to generate recurring revenues as we value up customer needs. Website traffic. We should know that what number of users daily visit our site as they might be interested in buying our EV vehicle. Operational metrics. Production throughput. A company have to take in notice the number of vehicle produced in day. Even we need to keep track for an R2 defect rates. This calculates the return due to defects of or number of post sale issues in our product. First pass yield is percentage of vehicle passing quality checks without network. Charging efficiency and battery life metrics. Energy consumption per mile also need to consider the charging cycle of a vehicle. Operational expenses. Record of cost needed to assemble a vehicle, rents, inventory, machinery used, salaries and other cost. Cost per hire. It is the total cost needed to hire and employ in firm. It too includes the advertising cost, recruiting processes and else cost. Sustainability KPIs includes emission avoidance percentage of recyclable materials used.
7. Use of product solutioning concept and create a mind map for the new version of the vehicle. Explaining the goals, features, UX changes and UI changes if any you want to target in the scope. Goals. Enhance energy efficiency and reduce carbon footprint. Second, improve user satisfaction and retention. Third, increase competitiveness in the electric vehicle market. Fourth, optimize production costs while maintaining quality. Features. Advanced battery technology for extended range. Second, smart navigation system with real-time traffic update. Third, integrated safety features. Fourth, voice controlled operation for convenience. Fifth, over-the-air software updates for regular enhancements. UX changes, simplified onboarding process for first-time users. Second, initiative app interface for better connectivity. Third, enhanced accessibility features for diverse user demographics. Fourth, personalized driving analytics to improve efficiency. UI changes, modernized dashboard design with touch and voice controls. Second, minimalistic layout to enhance readability and usability. Third, dynamic color schemes customizable by users. Fourth, visualize data on battery health and vehicle performance. Eighth question, what do you think are the business matrices which are being used by the company to decide what to focus on for improvements and changes? What engineering matrices and measurements do you think should be looked at considering the complaints from customers? Do you also give reasons for the matrices and measurements you have selected? Matrices, customer satisfaction. Why it matters indicates whether customers are happy with the product. Net promoter score. Why it matters reveals how likely customers are recommend the vehicle. It's a trust and loyalty signal. Warranty claim rate. High rates mean there are post sale issues with product quality. Return or exchange rate points directly to dissatisfaction with specific features or functionality. Sales drop sales drop of points helps identify if customers are deterred due to pricing, features or specs. Service cost per vehicle. Rising service costs often suggest design or reliability problems. Key engineering matrices. Matrices defect quality, defect density. Reason identifies which system, battery, software, drivetrain, etc. are more failure prone. Root cause frequency tracks how often certain issues like brake failure and others are resolved. Battery degradation rate. If customers report poor range over time, this shows how quickly battery capacity drops. MTBF mean time between failures. Low MTBF means frequent breakdowns or performance drops. OTA update success rate. EVs are now software driven and can have failed updates which may hurt UX. So this must be tracked. Charging time consistency. Customers expect predictable fast charging. High variation frustrates them. User interface error rate monitors how often user fail to complete tasks like setting navigation or pairing phones. Thank you.